Okay, so one of the ways that we use radians then are in the formula for arc length and sector area. So the formula that you used at GCSE, the theta over 360 times either the circumference or the area, depending on which one you were looking for, we can simplify those if we use radians. So our arc length, L, this part here, is r theta, where theta is measured in radians, and you'll see it described as the angle subtended at the centre. The sector area, so remember your sectors like your pizza slice, a half r squared theta, and your segment area, so this part up here that's shaded, is a segment, and it's the area of the sector take away the area of a triangle, and you know that the area of a triangle is a half AB sine C, so that's just it simplified down. And just one other thing then is about making sure you know the difference between the minor arc and the major arc, or the minor sector and the major sector. So you can see, like, it's sort of self-explanatory. The minor arc is the smaller one, the major arc is the bigger one. Okay, so our first one then, find the length of an arc of circle radius 5.2 centimeters, given that the arc subtends an angle of 0.8 radians at the centre. So it's a length of an arc, so arc length is r theta, so it's just 5.2 times 0.8, and that gives us 4.16 centimeters. So nice and straightforward. Second one then, the border of a pond consists of a straight edge of 2.4 meters and a curved part as shown in the diagram of radius 2 meters. Find C. Can we use our imagination now in this diagram that it's actually part of a circle as opposed to my dodgy diagram? Okay, so we want to find this arc length here, C. So we're going to need to find theta here. I'm going to find alpha, and then that'll allow me to find theta. So using the cosine rule, which hopefully you remember from GCSE, 2.4 squared equals 2 squared plus 2 squared minus 2 times 2 times 2 times cos alpha. So that's your a squared equals b squared plus c squared minus 2bc cos a. So our 2.4 squared, that's 5.76. 2 squared plus 2 squared gives us 8. And 2 by 2 by 2, that gives us 8 as well. So we get 8 cos alpha equals 2.24. So cos alpha equals 0.28. And then remember to have your calculator in radians mode, and you get that alpha is 1.287 radians. So theta then is going to be, remember they have to add up to 360, or 2 pi. So theta is 2 pi minus 1.287. So it's 4.996. And then to get C, we're using r theta. So our radius is 2. Our theta is 4.996. And we get 9.99 meters to 3 significant figures. Our third one then, the area of the minor sector AOB is 29.8. Given that the angle AOB is 0.8 radians, find the value of r. So this time we're given the area, we're given the angle, and we're trying to find the radius. It's the area of the sector, so it's a half r squared theta, which is 28.9. A half, there's your 0.5. R squared is what we're looking for. Theta is 0.8. Work that out and we get r squared is 72.25, and then r is the square root of that, which is 8.5 centimeters. Okay, and our last one. In the diagram, AB is the diameter of a circle of radius r. Angle BOC is theta radians. given that the area of triangle AOC is 3 times that of the shaded segment, show that 3 theta minus 4 sine theta equals 0. So I know that that looks complicated, but the important things to look for there, it's talking about the area of this triangle, and it's talking about the area of the shaded segment. So the first thing you're going to do is find those two areas. Okay, so the first thing we'll do is find the area of triangle AOC. So that's this triangle in here. So the first thing we're going to need to do is find that angle. Remember, this has to add up to 180, or pi, so we're going to call this angle here pi minus theta. So we're using the formula a half AB sine C to find the area. So the two sides, obviously if this is a radius, this has to be a radius as well. So it's a half times R times the sine of pi minus theta. So that's a half R squared. Now this is where you have to know your symmetries in your sine curve. Sine of, and think back to whenever you did the ambiguous case in the sine rule, the sine of 20 and the sine of 160 were the same. The sine of 30 and the sine of 150 were the same. So the sine of pi minus theta and sine of just theta are exactly the same. Okay? So the next bit asks you about the shaded segment. So we're going to find the area of the shaded segment. So it's the area of the sector, take away this triangle in here. So that's going to be a half R squared theta minus sine theta. Okay, so then the question tells us that the area of triangle AOC equals 3 times the area of the segment. So the area of the triangle, a half R squared sine theta, equals 3 times the area of the segment, which is a half R squared of theta minus sine theta. Hopefully you can see we can cancel the half R squareds on either side, and we're left with sine theta equals 3 upon theta minus sine theta. Multiply out a bracket. Bring our other sine theta across. And we get 3 theta minus 4 sine theta equals 0, which is what we were asked to prove.